I like the dance off to save the universe. I'm not convinced it's our core competency.
No. I'm not ready for the dance off. If the big bad villain, somebody else can handle that.
How you doing, Eric?
We write interpreters in languages I've never written a line of code in before.
Listen, I've been writing Rust professionally for tens of days.
We may be burying the lead a little bit, but tonight, we are going to attempt to write some Rust code, which I have never done. And we're specifically going to riff off of our previous couple episodes ago. We played with, I can't even say the name, Solidity?
Solidity?
I've
only ever seen it written down. This is the thing about technologies on the internet. You read about them and you never verbalize them.
I can't spell anyways, or read, but enough to understand the programming language. Anyways, we're going to play with Solidity is the language that Ethereum smart contracts are written in, which we can argue about how terrible or not that set of technologies is, but whatever. And we're going to play with the underlying VM.
Yes. Okay. Right. So we learned in the Solidity episode that Solidity compiles down to a bytecode that runs in the Ethereum virtual machine. And so I think what we're trying to do is implement the virtual machine.
Yeah. Oh, and by the way, I'm Eric. If you're just tuning in.
I said hello, Eric. Your name is written on the card.
And this is Adam. And welcome to Rubber Duck Engineering. Now we're really burying the lead. And yeah, so
let's do it.
Let's do it.
Code machine.
Happy Thursday, GFY. When is the next Godot stream? We'll get there. We'll get there.
We did it for a special. We did the first Godot stream for the 40th episode, so maybe for the 50th episode, we should do the second one. Put it on the schedule.
Well, so in the green room we're 46. What I don't even know, 46 episodes or something in now. We're starting to form opinions, and we have a whole backlog of stuff to do. But this sounded like fun for tonight, so.
Yeah, we have a doc of ideas for the show, and the ideas for the show grow way faster than the shows get produced.
So, to the code machine.
Cargo -- version.
All right, so the point was to write in Rust, which, as I said, is a language I've read a little bit of, but I've never written any.
So walk me through. So what have you done up to this point?
I've installed Rust on Windows. I didn't do the Windows virtual machine one or the Linux virtual machine one, although that was an option. And so I've made a new GitHub repository, which I've actually even published, this Rusty Ethereum thing. It's just empty. It's got a license file and a README. And then I think we wanted to use this cargo thing to make a cargo. You said it was cargo new something?
I've actually never done this step, but yeah, I think cargo new is how you make a new thing.
Cargo new. Aha! Cargo init.
Ooh. Always read that.
Cargo init.
Boom.
Yeah.
So what did it actually give you? Okay, so give you
a cargo toml.
Okay. Version 0.1. Oh, toml is Tom's obvious markup language, obviously.
Oh, obvious. I assume you're kidding.
No, it's called Tom's obvious markup language. It's absolutely what it's called. Yes, there's a whole community around Tom. Tom has wrote a sort of spec for the language. For a long time, he resisted writing an ABNF, but he eventually caved to community pressure and wrote an ABNF for the language. Although last time I looked, it was still marked as this is experimental. I'm not sure if this is the right ABNF for the language.
So you got to back up. Who's Tom?
Tom, he's the obvious markup language guy. I don't know. Tom will, okay, so turns out when you work on large software projects, you need config files all the time. And so the config file is the perfect bike shed because there's any number of choices and you can make any choice and it really makes very little difference to how well your system works, what language you write your config file in. And so we had to do a whole bake-off of all the different possible config file languages in the universe. Of course, TOML came up as an option, and so I had to learn about all of them in order to make some kind of informed opinion about it.
So you've written a TOML before?
A TOML file? Yeah.
Yeah, you have a 10-day opinion of TOMLs?
Oh, I've read the ABNF. I've read the spec. I've looked at examples. I've looked at his test suite. I've looked at how robust the other implementations are in all the other languages. I've gone deep into all these things.
Crazy.
For the record,
Okay.
we think JSON.
So we have a main. I'm sorry, you went back to using everything JSON?
That was the JSON 5 technically was the winner. JSON 5 is like they decided to HTML5 JSON and they said you can put in comments and some extra commas. It was going to be okay.
I was thinking about JSON actually the other day because I was doing some like JSON REST stuff. Like I was, pulling, and I didn't look into this enough, but I know there's things like retrofit and stuff that like auto generate, bindings for you. But there must be like a type language for JSON these days. Do you know?
Oh yeah. You want to know about config files? We can talk about config files for an entire hour. But like, I feel like we promised it a virtual machine. We should.
Let's maybe get to our virtual. So if I just run this.
Oh, you should do it. Get a Rust extension. They're quite nice.
Well, I think I did one.
Oh, but it doesn't know how to.
Well, I think I may just not have like rebooted the world here. So okay. Like if I close it and open it back up. Mm-hmm. Also, I chose the debugging one, which okay, fine.
Well, maybe try running it without a debugger. Maybe you don't have a debugger in your.
It only has 712 installs. Code LDB.
Just try running it without the debugger. We're not going to need a debugger. Oh, you need to go back to your source file. You're trying to run the help file. Which I agree, everything should be. Oh, really?
But I have a Rust extension installed.
Right, I don't think we should get sidetracked for this. Let's just try.
Okay. So is it just like cargo run?
Cargo run.
It worked.
Hello.
That was intuitive.
Hello, world.
Okay. Okay. So there's no way we're going to get full anything resembling an interpreter running tonight, but.
So negative. Well, let's try. So we found a spec. So should we pull up? Oh, we had the thing with the diagram of like the picture of what one of these things is supposed to look like.
What do you mean the picture? This, right? This?
No, the third tab in your thing here. That picture.
Yeah. EVM, Ethereum virtual machine, EVM, from ledger to state machine.
This thing. Okay. So inside your state machine, you're supposed to have a program counter, a gas, a stack, a memory, and then some storage.
Yeah, that's all fine. Like that all seems pretty. Whoa. Okay.
Yeah. So you apply it to your state, you get a new state, and then it's built around a stack. It's a stack machine.
Instruction stack machine. Okay.
So there's 1,024 items, each of which is 256 bits.
Giant instructions.
Mm-hmm. So I think we should just start coding this up. Like we should just declare all of these things and start.
I mean, I would love to see what "Hello World" in EVM looks like. I mean, you're not going to be able to read it, right? Because it's.
We can just type it out. Like, why don't we type out a thing that adds two numbers? Like, it pushes two values and then uses the add instruction.
Yeah. So like, we should find an instruction list.
So that's your first tab, I think. So one of these instructions is the push instruction.
Use any opcode.
Mm-hmm. Like push one. Yeah. So opcode 60 takes a uint 8, pushes it.
Okay.
So, and then I assume there's an add that will pop two values and push the addition.
Oops.
Yeah, opcode 1. Right? So I think
it's 256. And what does it do?
So it takes the top two items on the stack and puts back their addition.
Ah. Oh, okay. Yes, here's the stack. Yeah, okay.
So I think we could write a simple program that was just push add.
And the stack is always 256K or 256 bit units?
Yeah, I think each element of the stack is 256 bits. So when you push this little tiny 8-bit value, and then it consumes 256 bits on your stack.
Okay. Okay, so our like MVP here. we take an instruction input buffer, and we execute, we pop them in a loop, and we execute. And our initial instructions that we're going to implement are add, which is 0, 1. It's just, yeah, 0, 1, that's fine. And push 8.
Please push 1.
Push 1, which is 60, I think you said?
60, yeah.
Okay, 61.
And so, yeah, so the push 1 takes an immediate.
Oh, I see. These are hex, by the way.
Oh, okay. We should note that carefully.
That's, I don't know how you note what the hex.
It's a 0x in the beginning.
In Rust, 0x.
Yep.
Okay.
I've lost the editor link, by the way. When you restart your editor. But,
oh, sorry.
No problem.
I believe that's shared with you now.
Great, thank you.
You should see it in your list and be able to just join. If you can't, I can send you the link. Okay, this seems reasonable. So we get back to Eric has no idea how to write neat. Like, how do you even declare an array?
Oh, I would start by declaring some types. Rust is very type oriented.
Okay.
So you'd say struct, curly brace.
You can type too, by the way. Did we get you fixed?
I did not get fixed, unfortunately. I'm sorry.
It's fine. I just have to close my screen for 2 seconds while I fix you.
Yeah, so the just to tell the audience a little bit about Rust. So Rust is similar to Go in the sense that it doesn't have subtyping. Instead, you create structs, and then you declare traits for those structs. Unlike Go, it doesn't automatically deduce the traits for you. You have to explicitly declare the traits.
Okay, so you have the link, but also you said we're doing struct.
Yes, I would start by just making a struct for like the maybe the stack.
Okay, and is it like trailing like that, or?
No, it's like that.
Okay.
No semicolons, yeah. And then, so what did they decide? It was so we're gonna need a type for like a one of these 256-bit words.
Yeah.
Maybe for now we should just do 32-bit words.
Yeah, I don't think it matters for now. We can always change the size.
So this is the way. So this pub means this is a public value. You can access it from another file. This is the name, and then the types go after that. So values going to be let's see, what's our way of doing this? I think it's a word, and then they had 1,000 of them.
Okay.
This is a inline array of 1,000 words.
Okay, makes sense.
And then if you want to start putting methods, now you start saying impl. You say fn for function. So let's do add.
So you don't do it in the. Okay.
And then if you want access to this variable, you have to declare it like this. So ampersand means a reference.
Yep.
So a reference is like a non-nullable pointer. Mute means this is a mutable reference. So unlike C++ where things are mutable by default, in Rust things are immutable by default, and you have to declare whenever you want mutability. So then self is the keyword that means the self.
As someone who wrote C++ for a decade, this all sounds sane so far.
It makes a lot of sense to C++ development. In fact, I find myself writing, like the more I learn about Rust, the better C++ I write, because I write C++ that could have been Rust, which has much simpler ownership semantics to it. So I think we also need like a stack pointer, right?
Yeah.
The U size is unsigned like a signed T.
Mm-hmm. What's the I? Is that just?
Is the name of the variable? We can call it whatever you want, like the index. Index.
What do they normally call the stack pointer?
SP? Stack pointer.
Is it SP? I feel like that's a common thing to know what your stack pointer is. Like, what does the processor call it? Whatever it is.
The processor calls it SP.
Okay.
So I'll just make a constructor for this thing while we're here.
Function new returns a stack. Okay. What were we writing in last week? We were writing in a different language. That I also Go.
Oh,
Yeah, this looks somewhere in between C++ and Go so far. Values, yeah. Okay. Why word default? Oh, I see, because we want to let it decide what 0 should be or whatever. Whoa. Okay, what's derived default here?
Okay, so Rust has an incredible macro system. So this is a macro like decorator thing. So somewhere there's something called default that will eat this syntax and will spit out for you some other code that gets incorporated in your program. So what this spits out for you is an implementation of the default trait that basically will zero initialize this whole structure. I don't know why this is mad.
It says mismatch types. This must be the default macro.
It's possible we could actually just derive default for stack. And it would zero all that stuff out for us, and we won't need to write our own constructor. Easier. Well, let's see if we can actually initialize this.
Word trait bound is not satisfied. The trait is not implemented for word. I see. There's no default for word 124. Following implementations. Wow, you're like way into C++ land here.
So why don't we just do this? We'll make this variable sized. Okay. Now, vec is like a std vector, so it's a variable size vector.
Okay. Yeah, I could imagine we would change this again, but it's fine. It's our third line of Rust. It's fine.
So then I don't think we need a stack pointer because we'll always just use the last value.
Because it's variable sized. Yeah.
So I think we should try to write add.
Okay. So this would be like values dot pop, I assume.
Yes, we have to write self dot, and then let's go look at the docs for Rust vec.
How do you put something in a variable? Is it var or what's there?
I use let. Yeah. Pop. Okay, so this is a good thing to learn. So here is the. I'm going to copy and paste from the documentation here to show you the. This is the signature for pop. So pop returns a option. So option is like std optional. So it says either it's going to give you the value t or not.
Okay.
So we need to decide what to do in the case where we can't pop.
Well, this gets to, if we go back to this thing, there's like a halt instruction or whatever, right? Stop.
Right.
I think there's also like a self-destruct. We'd have to like look up what correct behavior for this.
Yeah, so I think more locally in our program, I think we want to, if you go back to the code, I can show you a neat Rust thing. So rather than returning nothing, we want to return something. I think we want to return is what's called a result. So a result is a thing that either your program can succeed, in which case you get back the thing of the first type, or if you fail, you can get back the thing of the second type.
Is this like T here? This is our just implicit.
Yeah. So This means this is unit. So this is the thing that like semicolon returns. So it's like it's an empty tuple. It's a zero array tuple.
Oh, so it's void?
It's void, yeah. So basically says when this program succeeds, when add succeeds, it doesn't produce any value for you. It just produces success. But when it's so then we need to define what kind of error we want here.
Also, I don't think add ends up on stack, by the way. Like add ends up as its own opcode thing somewhere.
Okay.
I mean, this is fine for now, but like eventually you have to do dispatch, right? You have some giant switch statement or...
Yeah, I think we'll get there.
But yeah, that's fine.
So if you scroll up, I just defined an enum for VM error.
Yep.
So I think what we can do here is we can say pop OK or VM error underflow.
Mm-hmm.
So what this does is it converts your optional into a result, and the success of the result would be the T, and the error of the result would be whatever you put in here. And then you use the amazing question mark operator.
What does the question mark operator do?
The question mark operator is the coolest thing about Rust, in my opinion. So the question mark operator says if the value is a result, if it's a successful result, if it's a success case, great, just return that. If it's the fail case, return from this function with that as the error. So that thing that you constantly were writing in Go in the last episode, like if not equals 0, return error, they've collapsed it down to question mark.
Huh.
Yeah. So I don't know whether this is success. So let's try to push that value back on. So let's say self.values.
Push, yeah. A plus B.
Yep. I think push always succeeds.
Mismatch types. Expected result found.
Oh, yeah. So at the end, we have to say, okay. We have to return the success.
And if this is like JavaScript and other languages where, like, if you just don't return anything, it returns the last thing?
Well, it depends on the semicolon. If you put a semicolon, then that's no good. You can say return and put a semicolon. But the cool kids go like that.
Oh,
I don't know.
God.
I don't know what proper style is, but that's...
Okay. I remember JavaScript because JavaScript was probably the last interpreter I worked on. And there's like a difference between now I'm forgetting the names. It's basically like an execution statement versus like an evaluate versus a whatever.
This is all lost in the fog of 15 years. Anyways, looks like you have a working thing.
Oh wait, we have our funny word type. So let's make a. Eventually, we'll have to like make words smarter and have operators and stuff. But
okay. Why do we? And this is just because we're boxing the.
Yeah, we
also use type def for this, right?
Yes. Oh, you want to do that? That's a cooler way of doing it.
This is fine too. Like we might actually want.
You do this.
And then just be done. And then we don't need this value stuff. We don't even need new, right?
Well, you need this.
What? What's the dot zero? That's self or something?
This we made word into a tuple, one array tuple, whose 0th element is this value.
Well, what about a type def?
We can do that too. I don't know how to do that. Because in the program that I'm writing in Rust, you really want to have, we could just say equals. You really want to use type safety. Like the reason I would declare this is because I wanted to treat words differently from ints.
Oh, and that's true. So that's fine. I think your previous, if that's the way to do it, if that's the way to get type safety.
This creates some type safety.
Okay.
I mean, really, we could do. I mean, how fancy do you want to be? Do you want to be fancy?
We're still doing Hello World here, so let's maybe cool our fancy jets.
Okay, let's just say okay. This is good. This should compile.
I've heard that is the challenge with Rust, is can you get it past the compiler? VM is never used, VM error, okay? Why is it not used?
Isn't it used right there?
Associated function is never used, add. Yeah, fine. Oh, I see, maybe this is like transitively.
Yeah, we can just do this. What is it? Bang, loud, dead code. That says, stop complaining that I don't use things. It's cool.
I love all your little secret Rust knowledge, your 10-day Rust knowledge here.
Well, these things come up because the compiler is really persnickety. It's like, you defined all these things, you didn't use it. I'm like, I know, I'm writing my program, back off.
Okay, so we made a stack.
Uh-huh.
Now we want, like, I would want to do something like let instruction equals vec, and I want like push one.
Okay, so let's write the instructions class. So that's going to be enum. There's going to be add, push one, which takes a U8. Okay, correct your code here if you don't mind.
Oh, please, I'm just writing imaginary code here.
Not that far off from the real code. It needs a lot more weird punctuation.
They're gonna make you explain all the punctuation. It doesn't auto wrap like Dart.
Oh, it does. If you have a formatter, it'll do all that for you.
Oh, it does. I have a formatter. Oh, come on, please. I installed the whole of the cargo. He was asking me before the show like how far I got, and maybe it was during the show. I was explaining this is not my first rodeo. And I installed the Visual Studio Code extension, at least 3 of them.
Oh, can I show you more cool stuff?
Please.
This you can just put right in here.
Sure. Oh.
And then you do this. You say, well, let sum. So it says, pop the thing off. If I got something, then give it this name, and then keep going in this loop.
Okay.
Then we want to match the instruction. And then we can put all of our stuff here. So we can say, time to add. Do that. When it's time to push. Do that.
Whoa. How did you declare these instructions? What?
Oh, enums. Oh, yeah, enums are awesome. So enums are like in ML, where they're just like
polar opposite of Dart enums.
Oh yeah. Enums are amazing. Like everything you want to do is an enum. Enum is really like a union class where you can basically declare with these tags what these different things are. So add is an element of your enum that has no parameters, and then push is a thing that takes a. It's just like we made word up here be a tuple that takes one value. This is a tuple, a named tuple that takes one value, which is this U8 int.
Oh, that's so cool. It's
I mean,
like a nicer.
Assuming it compiles, but
Well, I can turn that back on. Let's see. Cannot find tuple struct or tuple variant. Push one in this scope.
Maybe we need to make more. I mean, I could do vertical selections.
Well, I don't understand why one of them is highlighted and one of them's not. Like one of them's like, does add need?
We can do like that.
I just don't know. Okay, cannot borrow instructions as mutable. It is not declared mutable.
Right. So it became const, right? So you got a vector that you can never change. So now you need to say, actually, I'm planning to change this vector. In fact, I'm going to pop it.
Unused stack variable. Yeah, we'll get to that.
We'll get to that.
Okay. I think we're okay. So let's do push one. This is going to be stack dot push.
I mean, this feels a little bit redundant. I kind of wonder if this thing should be operating directly on the stack. Otherwise, we're going to be declaring these little trampoline functions in stack all the time.
Oh yeah, like I think stack is just data. I don't think these things end up in the stack.
Well, we could put the execute function on the stack, like we just say fn execute.
Oh, maybe. I think you're going to end up. Yeah, I don't know how that's all going to sort out.
Right, or we could just move this down. Do you want to?
I would just move that down into the. I would just write an infinitely large instruction trampoline, and then we'll split it out later.
So we still need to figure out how to do the error handling here.
Oh, I see.
We may want to move this. Yeah, we may not literally want to put it in main. Why don't we just make this a function called playground or something? Because then we can declare a better type for it.
Oh yeah, like we could totally have this be an execute function, if nothing else. That makes total sense, right? This little matcher, I don't know where you took. Oh,
did I break everything?
No, I cut it, so it's in my page buffer.
Oh, so you want to make this execute?
Right. So then
execute instructions.
This is VM error. Let error equals sum. I don't know.
Well, you don't ever want to do that. You always want to use the awesome question mark thing. So like we should have a function called playground that returns results.
I don't understand what the playground bit's about.
Just getting us a place to work that we can have a return type for.
Oh, I see.
And then main you can call playground and say whatever it is. Line. Fun. Error.
What's the bang for? Exclamation point.
That means this is a macro. Just warning you. That's what allows it to do this like variable argument thing, is because it's actually a macro.
Oh, I see. So var args is a macro thing in Rust?
Macros are incredibly powerful. So among the things they can do is variable arguments. Yes.
Huh. Okay. Okay, I cannot find type instruction in this scope. It's probably instructions.
But I think this should be instruction.
Okay, makes sense. Yeah, instruction. And
so we need values.push.
Oh, yeah, I actually don't know whether this execute.
Word.
Yeah, I don't know if this is the right. Well, this allows you to return an error, yeah, which you'll want.
And then when we're all done, we'll say okay.
But you need to pass the stack into here.
That's why I thought maybe it should just be a thing on stack.
That's fine. We can try that. I don't know that it makes sense to have the execute. Well, let's try something. It really doesn't matter. You put it wherever you want it to go.
Let's pass in the stack.
Because I also don't have like a sense for this yet.
So the stack you're going to need to borrow is mutable, because you're going to mutate the stack. And here we need to say mutably borrow the stack. And here we're going to say, actually, the stack that we made, we're planning to mutate it.
Okay.
And then here we just want to say question mark. And then we're going to say okay at the end.
I see, and this okay is a void okay.
Yeah, you're returning this tuple with 0 things in it, which is the idiom for I don't have anything to return.
And these are instruction instead of instructions. This match type on void, and we should have a result. What?
Match type. Oh, we don't need this here. Expecting to found U8. That's here, right? So, so this is always something that I'm currently doing wrong in the Rust code that I'm writing. So I keep writing it like this, but the Rust people tell me that's a bad idea because if this conversion goes poorly, this will cause a panic, which is like a crash. And so there's some better way of doing this that either guarantees success or lets you handle the error, but whatever. Like
yeah, that can be episode 2.
We'll get there.
When you've had 17 days of professional Rust, and I've had 2 hours of non-professional Rust, hobbyist Rust. VM error does not. Oh,
we should fix that. I tried to print out the error, but I didn't actually.
You mean FTM or FMT?
FMT.
Okay. It's so like Go and C++, a little of this, a little of that, kind of combined.
Yeah, they had a crazy.
Yes. There's heredity here. Inner attribute is not permitted in this context.
Oh,
Inner attribute, like no standard, annotate the item usually found at the beginning of source files. Oh, are we supposed to move this up?
Yeah, sorry. And then, actually, I think we could just do.
VM does not implement format display.
Right, so I think we just want to derive display here. Derive debug display copy clone partial EQ EQ. I don't know, that should be enough.
Okay, the macros are cannot find derive macro display in this scope.
Okay, how do you derive the display?
Is it FMT?
Maybe you need to import it. Oh, maybe they can't. Oh, let's just try. We can just use debug. We just want to debug, right? So that's like : ?
Whoa. Where did you : ? Whoa, hello.
Yeah, so that's my format specifier. My format specifier is give me the debug thing. So this is actually my main criticism about Rust, which is every solution to your problem is some magic character sequence that is totally ungoogleable. So like, what it would have taken you to get from don't have display to : ? Is like the only way I know how to do this is to have a like Rust friend you can call on the bat phone and be like, what do I do?
So I think there's another way, and I've been wondering about this for a while. It's like, I think that there could be some better search tools for programming languages than we have today.
Yeah, that understand things like : and ? and all these crazy.
There's
just ignore that. Be like, you filled out on your keyboard. You made a bunch of random characters.
Why is the search tool that I use for my programming language the same as I use for like, finding something to buy on eBay or whatever? Like they're very different operations. You wouldn't use your kitchen shears for brain surgery, and so I just like I think it'd be okay if we had a scalpel. Anyways, hello world, error, underflow. Okay, that's something.
Cool. Why do we get an underflow?
Well, we might have to learn how to use Rod's debugger here. Okay, what do we got? Playground. Error, done. Okay. Playground gets a stack. Push. Can we print the instruction that we're executing like this?
Sure.
I don't know how to print. Print line. And then you said it was like, I don't know whether Rust is, no. Do I have that?
So you need the bang after the print line because it's a macro.
Oh, bang. Yep.
And you need the curly braces around the thing. Curly braces mean I'm going to substitute something.
Okay.
And then the thing that goes inside the curly brace is like information about how you want it formatted.
Okay. It, I bet, doesn't have the debug and whatnot.
Yeah. So why don't you go see if you can use this technology to make it debuggable.
I appreciate that you are scaffolding this for me.
It's like once you have enough stuff to start copy and pasting, you can make things work.
Do I need or want any of these?
Yeah, why not? Leave them all. Why not?
Okay.
You can always take them away if they cause problems.
Add.
Oh, because we're going backwards. We popped. If you go down to your execute loop in Playground, you said pop, which took the rightmost one.
Pop first? Like, what is the?
We want to iter. ITR.
Oh, interesting. Because we're just assuming it's immutable.
Right. So then I think iter is for instruction in there.
Mm-hmm. Yeah. Okay.
And now I think we'll run them in order.
What's the mismatch type? Instruction found at instruction. Yeah, we don't need.
So right. So what's going on here is we're trying to. So by default, it's move semantics. So when we wrote this, we said we want to consume an instruction. So actually what we want to do is we want to borrow the instruction.
Okay. How do we borrow the instruction?
Just like that. So this, you can't see it here, but this iter is not destroying the vector. Instead, it's letting you borrow one element at a time from the vector.
Yeah. What's the just like? I didn't see what you did.
What's the what?
What was the just like? What, the star that I did? Or what?
Oh, sorry. Leave the star out for now, but look on line 22. I added this ampersand here, which says, I don't actually want to consume an instruction. I want to borrow an instruction.
Well, okay. For my C++ eyes tell me you just want a reference to the instruction.
Same thing. Reference and borrow is the same thing.
I see. But it's not a mutable reference.
Correct. It's an immutable reference. So it's like a const ref.
And this cast is now invalid, it says.
Right. So now we actually want the star here. Because we ultimately had, so this then became a borrow of the value. And so then we want to say, actually copy out the value and put it in this word.
Okay. Yeah.
We did it.
We did it. Ship it.
So I think we should write a decoder to decode the instructions from a buffer.
Yeah, and I want hello world too. But yes, we need a decoder. Do we have like some simple examples?
We could just write that program as a thing we wanted to code.
Oh, sure. We also need an encoder then too.
Sure, let's write an encoder.
Okay, how do we make our enum fancy or to have numbers?
Oh, you want to like associate numbers with
it? We should store as close as possible to the names what their number encoding is, I think.
Mm-hmm.
In a DSL world, I would try to do that. A domain-specific language world.
I'm sure with some fancy macro you could do that, but I no idea what that would be.
Okay. Sorry, I'm making my things disappear here. Okay, well, so I guess instead we will.
We've gone with a very structured approach here. Like another possibility is we could teach our execute function the numerical values to execute. Like it could be scanning over it could do the decoding and the executing at the same time.
Oh, that would be fine. We just want aliases for the.
I think we may just keep going with the structured approach, and then maybe in a future episode we could try an optimization where we remove some of the structure and benchmark the differences.
Does this end up being in the instruction stream then? The value?
The immediate, yeah, it's an immediate.
Mm-hmm. I see. Yeah, I don't think we want. I think you're right that we're going to end up wanting to do that. We're not going to want to decode into the structured instruction stream and then execute. We're just going to want to execute in our loop.
Okay. Do you want to jump directly to that, or do you want to write it?
What do we got for time? We got like 15 more minutes.
let's try it. Let's try that. So then instead of enum instruction here, we want a bunch of consts, right? Like const
Sure.
add op is a U8, which is, what do we decide it was? 0, 1.
Mm-hmm. Yeah, it's right down here. 0, 1. Push is 0, 60. What's the U? Unsigned?
Yeah, I think I don't need all these U's. I would U crazy.
Something's upset with you. Suffix U for a numeral literal.
Whatever. Add which one up?
Feels weird to me that they trail with op, but okay. Like, shouldn't be op underbar add?
Whatever you like.
I'm just thinking for like namespacing when you want autocomplete, but I'm overthinking it, I'm sure. Okay. Yeah, we kill that.
So kill that.
See, we don't have deleted. Okay. So, we kind of don't want these to be U8s.
I think so.
I guess
yes, we want the instructions now to be like vec of U8.
I mean, we don't really want a vec. We want like a stream.
A stream.
I don't know what types we have available to us, but like we'd want a view into the vector in like C++ land.
Yeah, so we want a slice, which
Sure,
I think is
slice would be fine.
I think, what is the type for slice? Oh, you just do this. Okay, slice just is a square bracket like that.
Okay.
Of,
and here we would kind of like didn't we have some type def before? Type def. So okay, type. Because this you want for no other reason than you're going to change these from U8 to U20 to 56 or something at some point, right?
Yeah, possibly.
Okay. Stop caps. Okay.
So now we need to pull each instruction. So then this becomes op add.
Yeah, I actually don't think you end up wanting to pass the instructions itself. You want to pass some container because it's somebody else's job to like move the instruction pointer and give you the next one.
Okay. So do you want to? So maybe we should make this into like a struct somewhere.
Like if you had like a struct instruction stream, you know, something like that.
Yep.
And then I don't know what it's not let. It's like your IP. I actually don't. Maybe it's not you. Maybe this is like a.
That's a U size, right? You're gonna use it as an index.
Well, do you actually want an IP or do you want? Well, that's fine. You can start. I mean, you want this instruction stream is like an enumerator, and you want an enumerator that you want to be able to say next to.
I mean, they just have that. That's called an iterator.
Yeah, I think it would be totally fine for this to be an iterator then. This instructions as a start.
Iterator. Okay. And then we want to match let some instruction equals
It should be probably the caller's job to, like the instruction you're passed in, because like the 0th instruction you execute, right? You're not leading with a no op.
Okay, so you want to say like op is an instruction. By the way, I have more instructions in case you need them. Is that what you're saying?
Sure, unless you have a peak operation. But yeah, that's fine.
And you can say push. Say next or okay or add op. I don't know what kind of error you want to return when you.
Oh, that's fine. This trait takes 0 arguments, but 1 type argument was supplied. Iterator takes 0 arguments? That can't be true. Trait are objects without an explicit dying or deprecated? What does that even mean?
We're getting to somewhat fancy things, but at the top I'm going to put a use for iterator. We actually go find it.
I feel like all of Rust is fancy.
Iterator is particularly fancy if you want to pass it around as a right. Okay, here's how you want to do it.
I mean, like, you also could imagine passing like your instruction cache object, right? That has a give me the current instruction as well as move the instruction pointer as like two different methods on it. I just don't know how to design something rusty. I don't have any feel for that.
That's fine. So you do this with a type constraint where you say, you're going to give me some type. I don't know what it is, but I need it to have the iterator trait.
Okay. Crazy pants. Can't find I in the scope.
Where's I?
It's the font's different, but I is this mute I. Did this need to be like declared with a like I, something like that? Can't find instruction in this scope.
Oh, that's because it's now called op.
Okay. Okay.
Yeah, I think I want to make sure this is an iterator of instruction. No way it's mad about the type.
Trait takes 0 type arguments, but 1 argument was applied.
All right, so that must not be the way of saying that you get a. How do you tell what you're iterating over? Make it happier.
I went to go.
Oh, I see. Item equals. I'm reading the iterator of. Try that.
Okay. No associated item name, push 1.
All right, so now we need to make our new vectors in the new format, right? So it's like push 1, push 1, do, op, add.
Yeah, that makes sense. Okay, function takes 3 arguments. So
we just have to say let mut iter equals this. Because we need to have access to the iterator.
Mm-hmm.
And now we need to use our while let sum op.
Mm-hmm. Iter next, yeah.
We pass in the op,
mm-hmm.
op and the iter. Borrowed iter.
Uh-huh. Mismatch, resolving, slice.
Oh, I think we may need to be more specific about what kind of vector we want. We want like a U8 vector here.
It's actually an instruction vector, but yeah.
Okay, that's a good point.
Mismatch,
Expected U8 found reference. Did we order these things wrong?
Oh, we want a borrowed instruction.
No. Borrow without explicit lifetime name cannot be used here.
Got a name. It's got the same name as this.
Can we roll back a little bit? Like I'm not sure that was the error. Before you go into total crazy town. Named lifetime borrows.
Rust is crazy, man. It's totally crazy.
Oh my goodness.
But this is what Rust programming is like. You write your program, you're like, okay, I'm pretty sure I wrote the right code. Now I need to like browbeat the Rust compiler into accepting my code by spamming all kinds of annotations to convince it that I'm not going to crash.
Oh, all magic pixie dust too, because they don't use more than 2 characters.
Right, like -A. Like, good luck googling that. Okay, let's take away the -A. I think we went a little bit too far.
Yeah, I think we went to crazy town. Let's come back.
So
maybe just like a crazy Hamlet here. What is even? All right, this 38 word push. What is that?
Okay.
Is that right? All right, hold on. All right, this thing. Without its lifetime, we don't need that. Yeah, okay. Type its match. Slice as standard. Expected U8 found reference. Where's the reference?
Oh, I bet it's the op. Let's dereference the op. How about that?
That did not change. Okay. Type match misresolving slice.
Iterator, blah, 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 as...
Oh, I see. Because are we saying that the slice is the same as...
Okay, so we have a slice iterator that expected U8 found reference. No, U8.
Okay.
Right. Yes, I'm pretty sure the iterator that we have is giving us back references to U8s instead of actual U8s.
Mm-hmm. That seems consistent with this error message.
So we need
Why
to
does our iterator do that?
Why does the iterator do that? Because we're ultimately borrowing the memory that's in this variable.
Okay. So would we make it happy if we just made this a borrowed instruction?
No, it's entirely this third parameter that's causing us trouble. So
but
the
third parameter is trying to match with the second parameter. Right?
Well, instruction is a concrete type. So that's...
What time did we do that? Oh, I don't know where we do it. Expected. Now we got a different thing.
Yeah, I don't think we don't want to do that. We want to take that. So we will give a very general iterator type here. We could just say this is an SCD slice iter.
Expected trait found struct.
Now we're very specific about the kind of iterator we want to type. Okay.
Expected trait found struct. Not a trait.
Not a trait.
Right.
What's a trait?
A trait is like a ADC, abstract base class.
This struct. Oh, stop it.
You have one reminder.
Yeah.
Today at 8:30
Yeah,
p.m.
I hear you. What is going on? Casting? Oh, we're now to a different error, so that's good.
That one I can fix with a star. Bam.
Non-exhaustive patterns. Yes?
Okay.
Can we tell it that? Oh, yeah.
We say
Bad op, yeah. Wasn't that just, isn't it VM error?
Yeah.
Is it
with Rust, we specify everything.
We did it, team. The good news is, after you're done fighting the compiler, the program usually works. you spend all your time fighting the compiler, and not a ton of time debugging the program.
So, okay, what did we do here?
Okay, so the main thing that we got us unblocked. Talking in general, or just what got us unblocked in the last 5 minutes?
No. Like, what do we have working here? That's what I'm trying to.
Oh, we have a basic Ethereum VM interpreter that can handle 2 opcodes: the push opcode and the add opcode.
Can we print the top of the stack?
Sure.
Would be do. We don't have the stack here.
We can just return the stack here. We can also pass in the stack. Maybe we should pass in the stack.
Sure. I'm not to the level of like being able to write this cryptic syntax from memory yet. Need a little more practice.
Yeah. Want to print out the whole stack? We'll just do stack that.
Sure. Does that need to be? Huh?
Nope.
Word does not implement format debug. Yeah, we didn't copy it.
You know how to solve that one.
More pasta.
More pasta. Yeah, you add default.
You doing it? Looks like you're doing it. Cannot mutate or cannot borrow stack as mutable. It is not declared as mutable.
All right. So it's already a mutable reference. So we don't need to do that anymore.
Okay. There we go.
There we go.
We have a word 3. We did it. We did it, team.
We did it, team. A lot more to go to make a fully functional virtual machine, but the basics are
there. That, I mean, I need to like bask in the rustness for a little while, I think. Maybe
yeah, it took me a while. Like for a while, I could copy and paste Rust code and get things that kind of worked after fighting the compiler. After using it for, I don't know, maybe like 20 days or so, like I could type out that level of Rust code, which is very far from the, what?
I thought you were 10 days into professional Rust.
Tens of days. I don't know.
Oh,
it's like,
tens of days. Oh,
tens of days.
You were a sandbagging pro here.
Anyway, like I don't really know how to do the iterator thing properly. Like as you can see, like that's a little bit beyond my Rust foo.
I predict that you will know by next week.
I did write a macro. I found a thing where I needed a macro, and so I started reading the macro docs, and it was like, whoa, that rabbit hole goes deep. Let's do the basic one.
Yeah. Anyways, this was fantastic. So fantastic, we've even gone over time. So thank you to our viewers for sticking with us. It was wonderful to see you, Dr. Barth. Do you want to give any update on the pizza before we depart?
No change to the pizza. We haven't made.
No change to the pizza? My little alarm that was going off was telling me to put out leaven because Friday morning is Friday is when I bake bread. Saturday I actually break it, but you have to like let it rise on Friday. And so it was telling me to put out the leaven so the bread will be ready to like put together tomorrow.
Oh, right on.
But no pizza for us. But we did. Oh my goodness! Now that my wife and I are both fully vaccinated, we have gone out twice.
My gosh.
We have left the house. It's amazing.
Is the world still there? I hope so.
The world is still there. It's actually, so we went out, we went to some nice restaurants as we used to do. We used to go out on date nights every week. But we went to nice restaurants. It turns out the world is still there. Although the restaurants are like reduced staff and outdoor seating and reduced menu and all that. But it's still, it was nice to feel half human again.
Oh, I look forward to it.
Yeah. Anyways, Fantastic as always. See you in a week.
See you next week.